Hello, I will introduce how to build experimental devices using hobby electronics tools and how to automate devices you already have to perform biological experiments. There are good reasons to learn automation skills. First, there are many great easy to use electronic tools and awesome online tutorials for automating tasks these days. Building automation tools is very fun. It saves a lot of time and money, and it really impresses your boss. First, let's see how we can build electronic devices for experimental procedures. Arduino is an awesome tool for building any electrical devices. It is a small computer that can control electronic tools connected to it. It is extremely popular because with minimal electronics and programming skills, you can build totally amazing things. Again, there are lots of online tutorials on how to use Arduino, and it is only $8 or a bit more depending on vendor. Arduino can control diverse things. For example, it can control simple electronic components like light bulb, speaker, motor, heater, and it can control experimental devices. For example, the photo at the right is a peristaltic pump that can deliver liquid solution to your experiment. On the backside, there is an electrical switch that can be controlled by voltage signal from Arduino so that Arduino can control the pump. There are many examples of experimental devices based on Arduino. The first example at the left delivers liquid to multiple test tubes to perform experiments. The image in the middle shows a device that takes reading on optical density of microbial culture so that cell culture can be monitored. Also, a PCR device can be built as shown at the right. I'm in an analytical biochemistry lab, and we have great examples of Arduino devices for experiments. The device at the left performs chemical treatment of samples for mass spectrometry analysis. Also, Arduino is used to add certain functions of our mass spectrometry device shown in the middle. The Arduino device at the right maintains temperature of samples during an experiment. Each device saves lots of money and time and enables new type of experiment. Arduino consists of hardware, software, and user community. Arduino is programmed to control electrical devices connected to it using programming language called processing. Processing is quite simple language and it replaces having to build complicated electrical circuit to control devices. Arduino is first connected to computer by a USB cable as shown at the left, and on that laptop, Arduino board is programmed by Arduino software as shown in the middle. Arduino has a giant user community website where you can get tutorials for Arduino programming. How do you get started with learning Arduino device development? There are Arduino beginners kit for Arduino learning. You can purchase them from online stores like SparkFun's Electronics and Amazon for $30 to $50, and it provides all electrical components you need to learn Arduino and build simple electrical devices. Starter kits come with really good tutorials book that provide step-by-step guides and explanation so that you will be able to finish the tutorials very easily. This guide provides basics of Arduino theory and Arduino programming. It is lots of fun and it takes one weekend to finish. This is a diagram of overall learning path. First, you learn basics from beginner's kit I mentioned, and you can also read introduction books from Megson. There are tons of great online tutorials from Smartphone Electronics and YouTube to learn basics. Then you move on to building your experimental tools by following or modifying building manuals available online. Academic journals with building manuals can be found from PubMed and ISI Web of Knowledge. Of course, Google finds manuals on almost anything you want to build. Also, Instructable's website has lots of manuals. These examples I showed earlier are actually not hard to build. These are based on simple kits available from online electronics mall. The point is there are great kits for many things and there are awesome software for designing things and there are great free tutorials and online community for building things you want. The fun is what you want to do with these amazing resources. The next section is about how to automate existing experimental devices you already have. If you learn one technical skill, you can automatically control all of the devices shown here, like robots, spectrophotometer, pH meter, liquid pump, electrical scale, a bioreactor, and mass spectrometer, and also multiple other devices. This can greatly help automating parts of your experiment. So what is the skill? The skill is knowing how to use serial communication to control machines. Serial communication is electrically sending commands for machines to perform. The photo shows serial communication port on backsides of devices. Through these ports, the devices electrically receives commands from computers. These ports may look familiar to you, and roughly speaking, you can control any machines that have these ports. Let me show how to use serial communication to control devices. First, you connect your device to your PC by serial to USB cable. The USB part of the cable connects to your PC, and the serial part connects to your device. Next, from the device manuals, you need to get information about communication configuration for your device. These informations are like phone numbers through which the device can be communicated. Specifically, you need to get information about four things called baud rate, byte size, parity, and stopbits. These are like four different components of the phone number, and you don't need to understand what these four mean to use them. Typical example values for these four things are shown in this table. 9,600, 801. So they are not, they are simple numbers. Next, from the same manual, you need to get commands for each function. For example, for a pump, you need to know letter C means starting a pump, D means stopping a pump, E means faster pumping, and so on. Finally, on your PC, you use popular software to control your device. The software receives instruction from you about how you want to control your device, and it translates the instruction into electrical signals to the experiment device as commands. Writing that instruction is called programming, but LabVIEW is a great software that enables bypassing programming. This photo shows typical LabVIEW program which can control devices by serial communication. As you can see, you use simple diagramming to instruct what your device should do. Also, those values from the device manuals are all inserted into the programming by diagramming to let PC communicate with the devices. Then LabVIEW sends electrical signals accordingly to your experiment device. LabVIEW is available to UIUC students at UIUC web store. If you can do programming, you can use Python programming on your PC to control your devices. This is an example Python programming program that controls an experiment device. If you run this program, the program will send the electrical signals to your device as commands. The Python code uses device phone number and commands that you got from the device manual to control your device. For Python user, I just blew their mind because they just saw how simple the code is to control devices. The behavior of machines are simply defined by short coding, and this is awesome. And my heart aches to see that non-programmers do not see the beauty of this simplicity. By the way, people, please learn Python programming. It is easiest and one of the most popular programming languages in the world. You have to learn it, and it is fun. I recommend Head First Python book because you should avoid dense, difficult books. Also, learning by books is better than online video tutorials. When learning coding, review study is critical, and online videos are terrible for reviewing. Lastly, know that coding can take a bit of time to start loving. Look at the graph at the left. Anyways, the amazing thing is, multiple devices can be controlled by a single PC simultaneously using serial communication. This can automate an entire workflow by automating multiple devices. For example, During my master's program, I worked in a yeast brewery, which is shown in this photo. Through my serial communication skill, I was able to control all devices highlighted in yellow box. That way, I was able to achieve near complete automation of 30-liter scale yeast fermentation. Learn serial communication, then you can control tons of devices. Combine your serial communication skill with Arduino skill, and device automation becomes your oyster. Finally, I hope to introduce hobby electronics and innovation as a sustainable lifestyle. First, our school has an awesome workplace called Community Fab Lab. It is a sanctuary for developing your skills and experiment during weekends. It provides great tools supporting staff, classes, and community for you to continuously have fun building things and grow. You can even make clothes, do artwork, and multiple other things there. It is open during weekday nights and weekends, so you can visit after work. It is freely open to anybody. Visit their website by Googling. You can bring friends there just as I did in this picture. More friends you bring, bigger the fun is. Building cool things with your friends while eating chickens and Pepsi, that's a good life. The people and the facility of Community Fab Lab belongs to a maker culture, which is a social movement. Maker culture is having do-it-yourself attitude towards creating technology and crafts. The rough idea is you don't need certifications, qualifications, degree, or license to do cool engineering work, science work, and artwork, or whatever, and you achieve this by combining your weekend work, Googling, and high-tech tools available these days. People in the culture are called makers, and they have innovators' mind. Makers form community workplace called Makerspace, also known as Community Fab Lab, just like the one at Urbana. They provide tools and volunteer teachers for your projects. This map at the left shows locations of makerspaces around the world, so it is likely that any city you go to has a makerspace. Also, makers host awesome community event called Maker Fair, where they present their work as public festivals. There are hundreds of maker fairs around the world, and the biggest one is near San Francisco, where they have more than 200,000 visitors per event. Urbana has an annual maker fair too. This is a screenshot of their website. You should visit their website for information about visit. The point is you have great community of people you can have fun with and grow with while innovating things. So what to do next? Get and complete Arduino beginner's kit in a weekend and try serial communication with your lab's electronic skill by LabVIEW and Python and go visit Community Fab. Thank you for watching.